All right, in this video, we're going to be talking about a Hamiltonian path. So let's get started. Now, before we do, let me just encourage you guys to watch the Hamiltonian circuit video that I created just to see the difference between a circuit and a path because they're similar but different. All right, so let's go and get started. All right, so a Hamiltonian path is a route that uses each vertex only once and a route that ends and starts at different vertices. All right, and all the edges do not have to be used. So, all right, so let's kind of go through some of this. All right, so the main thing to pay attention to, and that it goes through each vertex only once, and then it's also a route that ends and starts at different vertices. And then lastly, very similar to a Hamiltonian circuit, and that is all the edges do not have to be used. All right, so here we go. Here's a graph, nothing special about it, just a graph. All right, now remember that a Hamiltonian circuit would look something like that, just something like this, just to remind y'all. And, A to C, D, E, B, back to A. All right, so notice that I started at A, I finished with A. All right, now a path is when you actually start and finish at different vertices. All right, so let me give you an example. So let's say again we start at A. All right, so we start at A, and then let's just say we go to C, and then let's just say we went to B, we went to D, and then we stopped at E. All right, so notice again where we started at A, and then we stopped at E. All right, so there we connected all the dots, so to speak, but we started and ended at different vertices. So what we have here is a Hamiltonian path. All right, now here's where a lot of students tend to mess up a little bit, and that is what they'll do is again starting at they go to A, they go to C, D, B, and then they'll stop at B. All right. In fact, I didn't like how that worked. Sorry, my OCD is kicking in. E and then to B. All right. So they'll start at A and then they'll end at B, and they'll call that a path. In my opinion, this is not a path. All right, it is nothing more than an incomplete circuit. All right, so what you need to when you start and stop somewhere, make sure you don't end at a vertex where you can just easily close up and create the circuit. All right, so again, when you create your path, make sure wherever you start and stop, you just can't easily connect like this one right here. So again, you can easily just connect because the ending vertex and the starting vertex are adjacent, so you can just easily just close it in. So don't do that. So remember, whenever you start, wherever you stop at a vertex, then make sure it's, again, like the one I kind of showed you, like this one right here. I started at A, ended at E, and there's no way I can get back to E, or no way I can get back to A. So this would be the correct Hamiltonian path. All right. Now, unfortunately, there is no tricks like dealing with degrees when it comes to Hamiltonian path. It's one of those where it's just trial by error. All right. So, or trial and error. Sorry. All right. So if I start here, I go here, I go there. All right. So I can go there, I can go there. Uh-oh. I can't go back. I can't go back to that one vertex. So let's see if I can do it again here. All right, so let's see if I start here, I go there, 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 there. Oh, again, I can't go back. So I cannot connect the dots with this vertex or with this graph, so that will be a no-go for that one. All right, let's try this one. So let's say if I just start with A, I went down to B because I wanted to, C, I went to D. Okay, I can't go there. All right, so starting there was probably not my best start. All right, so let's start at E. Let's say if I went to E, I went to A, I went to B, I went to C, and I went up to D. Oh, there it is. Now some folks are going to say, well, wait a minute. What about this right here? Didn't you cross over right here? Didn't you cross over two edges? And the answer is no, because in a graph you can have two edges lying over each other, but that does not mean that it's actually that they're actually connected. So and like for example, if you start at E, you can't go to E and then hit here and then go up to D. It doesn't work that way. All right, so this is a straight edge. You have to keep following the actual direction of the edge here. All right. All right, let's try this one right here. All right, so again, a lot of this is just trial by error, trial and error. All right, so I don't know why I keep on saying trial by error, trial and error. All right, so starting here, again, just trying to get creative here. Let's see if I went there, 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 there. All right, let's see if I went there, 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 there. All right, now, question. Is that a Hamiltonian path or is that an incomplete circuit? All right, hopefully you would say that's an incomplete circuit because you could easily just keep going and boom, there it is, and complete the circuit. So remember, wherever you stop, wherever you finish at, you need to make sure you can't get back to the starting point. All right, so let's see if we can try this again. All right, so again, just let's say if I started, you know what? Let me start here. I'm gonna go in this direction. Oh, I don't like that color. That's a little too dark for this busy of a graph here. So if I started here, let's see. I'm trying to make it to where I'm not going to end here. Oh, I think I found a way. All right, let's see. What if I did this from here? Let's say if I went there, went down there, that way, that way, that way, went that way, that way. Oh, perfect. There it is. All right, so I started here and I ended here. So what I have here is a situation where I started and stopped at two different vertices. I connected all the dots, and I cannot get back to my starting point. So that is a true Hamiltonian circuit. All right, let's try this one right here. All right, so again, a lot of times it's really up to your creativity. So if I started with A, went down to G, F, E, B, C, D. Oh, that works. Again, I started at A, ended at D. I cannot get back to A. So that's one way. Let's see if I can figure out another way. Actually, let me see which way. Okay. All right. Let me say it one more time. All right. Let's see if we can try another way. So let's say if I started in this direction. Let's say if I went to D, F, G, go to A, go to B, go to C, and then go to E. Oh, there it is. That's another path. Notice I can't get back to my starting point. All right, pretty easy. All right, so I'm pretty much going to finish up with probably this one right here, just to put a story behind the graph. Just bring some more realistic situations here. All right, so the following map represents all the cities that need air deliveries. Mark was a pilot taking off at Miami Airport. Can you find a path that visits every and ends in Los Angeles? So all right, so he's taking off in Miami because that's what the directions say, and he's finishing in Los Angeles. Los Angeles, sorry. All right, so we got to find a way that can we find a path that goes everything. Now, well, I will. I just noticed something that we'll worry about in a second. So let's see if we can find a path. So if I went to Miami and if I went to Dallas and then went up here, JFK, Boston, swing it all the way around. San Francisco, and LAX. Oh, there we go. There's a path. Now, some of y'all might say, well, wait a minute, wait a minute. Technically, LAX and Miami can connect. Wouldn't that be an incomplete circuit? You would be right, but because of the fact that this particular problem actually says that the starting point is Miami and the ending point is Los Angeles, we're just going by the rules of the question. So, but yes, you would be correct. If we did not have these rules, meaning if we didn't have these directions, then you would be correct. Just by looking at this map here, you would say, well, this would be an incomplete circuit because it does not finish out, or it doesn't. LAX and Miami are adjacent, and you could just easily finish the circuit. All right. But unfortunately, we have rules in this problem, so we have to abide by the rules. All right, so let's see if we can find another one just for time's sake. We're probably going to end it after this here. All right, so let's say, I think I went to Dallas-Fort Worth first. And let's say if we went to, I don't know, let's say go to Boston first, JFK, that guy, Dallas-Fort Worth, San Francisco, boom, there we go. That's another way. And then actually might be a shorter way. But in path, how many total nautical miles will be traveled? Very simply, what you would do is you would just add up all the weights of each route that you took. So I would just add all these numbers up, and I would get my answer. I think 187. There it is. So add all this up, how many nautical miles will be traveled? Whatever all this is added up. All right. Well, that's it. It's a pretty easy concept, especially after already learning how a Hamiltonian circuit works. This is just very similar to that. But hopefully this made sense. Let me know if you have any questions. Thank you.